We are Group 7. In this video, we will be answering the question, can speed bumps and energy generators be combined? And if so, how much energy will they produce when, for example, a car was to pass over them? A car, let's say, a Ford Focus. Also, what are the environmental advantages and disadvantages to using this energy resource? And furthermore, what are the economic advantages and disadvantages in using this energy resource? So join me, Hamdan, Kaushal, Kate, Will, and Sam in the quest to answer this question. Thank you.
But how do the electricity generating speed bumps work, you ask? When a car passes over a speed bump, the speed bump pushes the car wheel upwards, then it returns back to the ground. The core principle behind this involves work. The work done is equal to the force multiplied by the distance moved. In speed bump context, this means the car's gravitational force multiplied by the distance it decompresses the piezoelectric sensor within the speed bump. Looking at the average UK statistics, the average car driven around is the Ford Focus, which weighs approximately 1,260 kilograms. The average height of a speed bump was also found to be 10.2 centimeters, which will be the height used for this model. The distance a speed bump can be decompressed can't be too high of a value, otherwise the car will get stuck in the speed bump. For this reason, the distance it can be decompressed will be 2 centimeters. So to work out the work done, the mass of the car will need to be converted into newtons. To do this, the mass of the car, 1,260 kilograms, will need to be multiplied by the acceleration value due to gravity, 9.8 meters per second, which gives a value of 12,348 newtons. This value, multiplied by the distance the speed bump is decompressed, 0.02 meters, gives a value 246.96 joules, which is the amount of work done. Now this value will be converted into power, which is measured in watts. To work this out, the work done will need to be divided by the time taken in seconds for the car to pass over the speed bump. We did a time survey on how long it took cars to pass by a speed bump on Pershore Road, and the average time taken for a car to pass over a speed bump we found out was to be 1 second. This led to energy being produced after a car passes over a speed bump being 246.96 watts, or 0.24696 kilowatts.
As we found out earlier, one speed bump can produce 0.2469 kilowatts of power for every car that passes over it. Now, if 150 cars passed over the speed bump every single day, that would result in the production of 37 kilowatts of power every single day. We also know that one street lamp requires 80 watts of power to be run. This means that one speed bump could power 463 lamps. That is a lot of lamps.
Facts on speed bumps. Now we know how the energy producing speed bump works, we can consider the facts about the energy it will produce and the price it will cost to install and run. Energy of the speed bump. During high peak traffic, these speed bumps can produce 36 kilowatts of energy. Just think of all that power. Even at low speeds, they produce 10 kilowatts. That's enough to power 12 microwaves. On a motorway, although we would get many cars, it would be impractical for them all to slow down over the speed bump. On a normal housing estate, despite the speed bumps being a welcome safety precaution, there simply wouldn't be enough traffic. But what about a fast food drive-through, or any drive-through for that matter? They will have a heavy flow of traffic, up to 410 cars per day, and the bumps won't make a difference in a queue. So although they may be costly, these speed bumps could be earning their money back by producing a ton of energy in no time.
Look at the advantages and disadvantages of the electricity generating speed bumps. The largest and most obvious disadvantage is the extremely high installation price at £20,000, which is an incredible amount higher than that for the standard speed bumps. There's three main areas where the advantages are found, as you can see below. Firstly, finance. The energy produced is technically free. Well, after 160 days taken for you to get your £20,000 back, assuming that 150 cars travel over the bump every day. Secondly, environment. The environment benefits as the production of electricity generally involves burning fuel which produces greenhouse gases. Thirdly, resources. The non-renewable source crude oil will be preserved as it is often burnt to produce electricity. A slightly different disadvantage to consider is that if the speed bumps were placed in drive-thrus as we've suggested, then fast food chains might use the eco-friendly energy production to their advantage when marketing, potentially affecting the health of the nation.
In conclusion, we feel that the advantages severely outweigh the disadvantages and would therefore advise the business to invest in the speed bumps.